My name's Dan O'Neill, and I'm a product engineer with the Android and Java runtime SDKs, and Eric Bader is one of our product managers for those products. And we're here to play nicely with our Java APIs. The agenda is essentially go over a little bit of the runtime architecture overview, and how that is today. Then go through what we're doing in open source, what kind of code you guys can get your hands on. I'm going to talk a little bit about example apps. Those were on the plenary today. That's a new thing, but it's a way for you guys to get your hands on even more sophisticated applications coming out of our runtime team. And then I'm going to talk about the open source geometry API and how we can leverage that in the runtime. So let's first start with the architecture of the runtime for Android and Java. So the runtime itself is built on a C++ runtime core. That's a way for us to share functionality between all the platforms, a lot of the platforms, and give us synergy between all of these platforms. Above that, since Java and Android share a language, we do a lot of common code implementations out of that C++ core into a Java coding library, common library. So that is all the business logic is in there. And then we have separate libraries for Android, and we have one for Java that does a lot of the view stuff and anything specific to the platform that we can't share. So while that's a nice modular picture and it helps us internally build our applications, it is not a modular API. So you can't take that green part or just run with the common core. If you get the Java, you get Java with the common. If you get the Android, you get the Android with the common as well. We are looking at ways to splitting that hopefully in the future and modularizing that a bit. And if and when we do, we'll be able to play nicer with our Java APIs. So at 100, we all get our SDKs through dependency management systems. So in Android and in Java, we have a custom Maven repository that you add to your list of repositories that you can go out and seek the libraries that your apps are depending on. And then with Android, we have a packaged AAR that you can go pick up as a compile dependency. And with Java, we have plugins for Maven and for Gradle. And what both of these do, a big advantage of these is you don't have to worry about any of the dependencies that we depend on at the SDK level. You pull in the one line of AAR, or you pull in the plugin, and you get everything you need to just start developing. And your time to developing it should be much quicker. I mentioned a public Maven repository. That's hosted for us on Bintray. And that's a distribution as a software as a service platform. And it provides a Maven repo so that you can go out there, use that URL, and go get it. It's a private repository for us. It automates our distribution. It gets our SDKs out to developers a lot faster. That URL is provided, and it gives us some statistics on our usage. So let's talk a little bit about dependency management plugins. So with 100, the way we get Java has been enhanced. So the fact that we were able to decouple the local server away from Java at 100 allowed us to treat it more like a SDK developer library. Now there's still dependencies on, like I said, some of that common C++ code, native libraries that don't come bundled in the jar, right? So you don't just go simply get a dependency management on a jar, but you can go get a plugin that'll manage all those dependencies for you. What's shown here is things like setting up your group ID and what version you're going to go get. And this helps with versions too, because you just when there's new versions released, you just up your version and you can go get the most available version for you. Same goes for Gradle. It's a little bit cleaner because Maven is XML based. Gradle is Groovy based. So with Maven, you use an XML syntax, and with Gradle, you have a DSL and Groovy that you can go and use. So it's really just one line of code to go pull that plugin once you've added our public repository to the list of repositories to search. And again, you control the version as a parameter on the plugin at the bottom. Update that to 100.0.1 when we get our next release, and it'll come and get it. Now, once you have these SDKs, whether they're Java or Android, it's a one-time go and fetch, because Maven and Gradle use the Maven repository local cache. So once you get it, you have it locally, everything's set up on your developer machines locally, and you no longer have to go fetch that. So you're basically working in an offline mode with respect to the SDK. So you can program against it without an internet connection. Not much you can do with the API without it, but you can program against it. So let's take a quick look at how that works. First, I am going to go to a non-IDE experience. So since, since it's all being managed by a dependency management build system, you can run this, all IDEs are supported at this point, or you can use any IDE you want of choice with Java. So that means you can run it from a CLI, command line interface, or we can run it from an IDE. So we'll just run a command from here, and you see the whole build comes out, and voila, you have your Java app that comes out. So it built the whole app, has all the libraries required, and you can run that from a command line. So that helps you in build server environments. Let's look at the same thing in an IDE. So in an IDE, we have our build.gradle file, which is here, and where we list our Maven URL here. So we basically are adding it to the repository list. You can have a bunch of repositories in there. We added here the one-line dependency to the plugin itself. You guys see that okay, by the way? And then here's where we add the version. And then to enable it to run, again, this is Groovy, so we have some specific tasks we can add, or parameters we can add. We essentially added a run command that told it what the main class was that allowed us to run it from Gradle, not from the IDE, even when we're in the IDE. So let's get out of presentation mode. You'll see some Gradle tasks here. You'll see a run task, and we could do more of an automated approach to running it. And there you go, same app. So you can run it. This is all being run through Gradle, but you can run it in more of an automated way through an IDE or through a command line interface. All those apps that I'm showing you right now at the bottom, if you get the slides, are open sourced for you on GitHub, and you can go see them and play with them. Next, I want to talk a little bit about where we are with open source and some of the Java projects that are out there. We do have a geometry API that's outside of the runtime. And it was created mostly to support big data analytics and some open source stuff happening on the server side. But it's a pretty good bare bones geometry API that can be used as the start for any sort of GIS application. We do have custom connectors for GeoVent extension server. That has been open sourced. So that's really good code if you're into GeoVent server because those extensions are available. And then within the runtime, obviously our SDKs are delivered through the mechanisms we just discussed, but we're providing a lot of code through open source. Obviously samples in Java and Android are out there, and demos like the ones you just saw and that you're seeing throughout the conference are typically put out in a GitHub repo. And additionally, for some platforms, and Android's spearheading it, we do have some example apps, which I'm going to get into in the following section, that are a little bit more end-to-end apps, hopefully starter apps, or potentially full-blown apps that are open source. So we have an apps group creating Collector and all those apps, but they don't open those source. So this is an attempt to get some of that functionality, some of that base functionality out as apps with the runtime and open source them for the developer community. So let's talk a little bit about the example apps and collaboration through that. Now, I'm going to use the context of example apps, but any of the open source repositories that I've mentioned, these sort of workflows are supported in. SDK samples, demos, or example apps, or the geometry, or geo extension servers, that sort of thing. So one way you can quickly find your platform on any GitHub is go to our Esri GitHub.io site and use the hashtag of the platform you're looking for. Android, Java, are there any other platforms? Qt, maybe? So again, Android SDKs out there, Java SDK, and all those example apps. And we welcome you to contribute to them and collaborate with us as well through those mechanisms. So they're all on GitHub, and the way GitHub is set up is organizationally. Our open source apps, we have a bunch of organizations for ESRI that we belong to, so we can clone, we get rights on them, we have teams, and we work within those apps. You as developers to the community are in your own organizations or are not, but you're not with ours. So in order to, you can clone any repo you want, and that will create a local repo for you, but you won't be able to necessarily sync, and you won't be able to contribute. So I encourage anyone who wants to, even if you don't think you're going to do this, to fork the repo first, because it's not in your organization. Once you have a fork, you essentially now, you do have a clone of it locally anyway. The advantage of this is you can sync back. So as you want to keep up to date with our repo, all you got to do is sync, and you'll get all the changes that we've been doing. That's very important to contributing, but it's also important to picking up new samples that might have come in, new demos, any updates to these apps that we're talking about. So beyond that, you can extend these now for your own use once you have them locally, and you can contribute if you fork. You can contribute by putting a PR against one of our branches that you've synced against, and then our teams can review and collaborate with you, and hopefully you can contribute code or documentation or anything to our repositories. So again, I do want to highlight, as part of our open source effort this year, these example apps. We're making a concerted effort, as I said, to put these, some are starter-based apps, some are end-to-end apps. We really want to open source them, and we really want feedback on what developers are trying to build. We're not just Android, it's just Android has sort of kicked this off. We have some .NET one out there you saw, if you watched on the plenary, you saw a map book that was a .NET app, and you saw a indoor navigation or an indoor routing app that was .NET. So we have other platforms coming up, hopefully iOS, potentially Java, and others. And out there today for Android, we have a Maps app. If you've been coming to developer summits or user conference for the last 4 years or so, you've seen that app. We've used it a lot. It's grown over the years to be a mapping application that you would expect on any mobile platform. So it has everything the SDK covers, a lot of high-level things, routing, geocoding, base maps, that sort of thing. We have a nearby app, which I'm going to talk about next. But that's basically an app that doesn't start as a map. It starts instead as a location-based app and tries to find things near you, and then gets you into the app space after that. And then, again, another plenary app we showed this year, our Ecological Marine Unit app, is a real big data app showing how to use definition queries against big data on a mobile device. I encourage you to check out all those apps. And again, I have listed on the left how you can contribute with us. So as we're playing nicely, the theme, I wanted to highlight the Nearby app because in creating that app, which starts as a list of locations that are near you currently, you need to get a location, and since in the runtime currently, the location's tied to the map view. So since we started out with an app that's not going to start with a map view, we don't have access to the location. So we need a location. So we went to Google's location API, and you leverage their location API to get that initial location. So that's an integration of another API. We brought in another dependency, and we got the location from Google. And once we have that location, then we can use that to search for nearby places within our API and present them to you on a map. So that's some code to give you an idea of how to do that. We do in the future plan to decouple location from the map view, but currently you cannot. So this is a way to solve that and play nice with another API. And I think I'll make an attempt to demo that for you. So we'll demo that workflow. So once this app starts, hopefully it'll find a location from our indoor location, and it'll find nearby places. Now the good thing about this app is we currently go out and get restaurants, bars, coffee shops, that sort of thing. It's very extendable so that you could take it to search for things that you want to search for. Let's say you want to do public schools, firehouses, that sort of thing. You can switch up what you're searching for, add to it. It also does walking distance. You could also, that's a negative thing. You can also do other types of modes of transportation to those apps. So what's happened here is we've done, like the code showed before, we've taken that location from the Google location service, found where we are indoors here, and returned a list of places that are near here. Once we start getting into picking one of these, go to the steakhouse, we send that to our API. And put it on the map. For some reason it's not zooming right in, but let's go. I got to change a lot of passwords after this. Try it one more time. And we're using our routing services. So we got the location from a third party. And we're doing walking distance. And so that's app. So again, I encourage you to go look at that and extend with it and collaborate with us and give us some feedback on that one. Okay, the last thing I want to talk about is the geometry API and how that can be integrated and why maybe you'd want to integrate it. So the geometry API, as I said, is an open source, not a runtime team. It's from the geometry team at Esri. They use it as a very lightweight geometry engine that you can go out and build starter apps with. Recommendations in the tutorials link it to the big data analytics that we do as a geometry engine for that. But one thing we have at 100 right now is we don't have direct support for GeoJSON, where the geometry API, the open source one, does. So if you wanted to put some GeoJSON points onto a runtime map, you'd have to do a lot of work. So using the geometry API greatly enhances the way to do it. And so the code here shows some of that. So we use and I explicitly put out the package so you see that it's not a runtime point, but we go get that point and send it a string of GeoJSON, and within that string, we can execute an operator from the geometry API that will return us a geometry object point from that GeoJSON. So now once we have that GeoJSON point, what we can do is we can take that point and turn it into a runtime graphic. And as a runtime graphic, we can add it to a graphics overlay, and then we could display those points on a runtime map. And that would look something like this. Right, so that's the app you saw earlier with those diamond points representing Seattle train stations through the city that came in as GeoJSON points. So let's take a look at how we did that. Okay, so I did this in a simple way. If you were going to get a feed of GeoJSON points or something like that, you'd want to do it another way, but I essentially just created 6 station points from the city of Seattle as GeoJSON strings. And then I have a create from point from GeoJSON method. Down here that I showed you on the screen, where we take that string in and we run this operator import from JSON executor from the geometry API. So this is geometry API code. We tell it what we want the defaults. We don't want to do anything funny with it. We know it's a point, so we're telling it to convert it to a point. This is the string, and we're not doing any tracking on it. And then we return that point. Now how did we get to be able to do that? Brings us back to Gradle. So you'll notice here, we added that API right here. So they're also out there they're an open source library, so they're out there, and you can go grab their library too. So now we have our SDK and the library there. So now once we have that as a point, the next thing we do is, so right here you see we have a COM core geometry point. We take that point, get its X and Y, and create a graphic out of it. So now we're creating 6 graphics out of that. And then we take that 6 graphics, we add that diamond marker symbol to it, and then we simply add it to the graphics overlay to display on the map. And as you saw last time, the end result of that is a runtime map, runtime graphics coming from open source geometry points. And with that, I'm going to let Eric talk a little bit about some of the older SDKs we have for Java as well.
Yeah, thanks, Dan. So as we close here, just a few other reminders that we do have other Java products that have Java APIs to them. Of course, there's the ArcGIS Engine SDK for Java. This is used for building standalone focused applications for Windows and Linux. I'll explain why Linux is red in just a second. We also have the ArcObjects SDK for Java. That can be used today for extending ArcMap with some add-in capabilities. As a Java developer, you can add in capability into ArcMap running on Windows to put in some of your custom Java logic that maybe you need to enhance the experience and get some workflows done for your ArcMap users. But also that ArcObjects SDK for Java is used for extending the server, right? And that's where really its strength is right now. You extend the server by creating server object extensions for custom services, or being able to build in custom behavior into how requests are made and responses coming back from the server, how you can intercept the requests and turn back the responses using Java. A great way to implement Java's server object interceptors using Java. So ArcObjects SDK, very useful and still a vibrant product for building server extensions on the back end. One important note is that back talking about building standalone applications using Engine for Linux, the 10.4.1 release of ArcGIS was the last release of Linux support for Java developers building Linux-based standalone applications, right? So it's important to know that through 2022, you still have time to migrate your applications from using ArcObjects Java on Linux to using either ArcGIS Runtime SDK for Java or ArcGIS Runtime SDK for Qt. So you have plenty of time to plan those migrations. ArcObjects Java and ArcGIS Runtime SDKs are two different models, as you probably know by now. So they're not really intended to be used in the same application. So they're different intentions. What's that? They don't play nice, but this is about playing nicely. They have their place. You build runtime applications, and you might be building ArcObjects applications. But to keep in mind that Java innovations going into our product lines are going into ArcGIS Runtime and ArcGIS Runtime SDK for Android as well. So just want to make a couple of mentions about that. And with that, I think we want to say thank you, and we're up here for questions if you have any.
Yeah, thanks a lot, and enjoy your conference, and let us know if you have any questions.